All right, good morning. In this video, we're going to cover sections 5.1 through 5.5 for the week 4 at Southern New Hampshire's Intro to Statistical Analysis class. All right, again, I highly encourage you to do the Smart Book reading and take notes, and that will assist you in completing the homework. So I'm going to click on homework 4-3 or chapter 5 and go through a couple of the problems. So for this first problem, we have cell phones of Samsung chips, right? And S is the event. So we always should define our event first, because knowing what our event is lets us find our probabilities, because probability is typically success over total, and therefore we can find what we're looking for, with success being our event and total being the total number. So, and they tell us what S is. So let S be the event that a randomly selected OLED display was made by Samsung, right? And so they already give us a percentage, which is 24.6%. So we're going to put that in decimal form, which is either divide this by 100 and move the decimal 2 places to the left. So 0.246. And to find the complement, right? To find the complement, all you do is to complement, the probability of S complement just equals 1 minus the probability of whatever event you're looking for, in this case S. So we just do 1 minus 0.246. So you grab yourself a calculator and then do 1 minus 0.246, and I get 0.754. If you want, you can check your work. And so we're good. Return to the question, because you want to make sure this part is correct before we go into C and D, because to find odds in favor is the probability of S, probability of success, over the probability of its complement. So I take 0.246 and divide it by 0.754. Okay, so I'm just taking these numbers of 0.246 and dividing it by 0.754. So 0.246 divided by 0.754. Gives me 0.32, 3 decimal places, so I get 62, so that's just 326. And then odds against is you basically flip it, the inverse. So I'll just take 0.754 and divide it by 0.246. And I get 3.065. Again, careful, this is good. Got to read, everything has been 3, but they did change this one to 2 decimal places. So return to my question. I went too many decimals, so 6.5 becomes a 7. There we go. Yeah, so always pay attention to what the software is asking us to round to. Annotate, clear my writing here so we can go into the next, return to the question. And then always remember to hit, no, not submit, sorry. You can hit save and exit, or just hit next. There we go. Submit's at the end. So this is another odds in favor and odds against, but this one they didn't give you the probabilities, right? So what we have to do here is take and find what they actually do. So we have the IRS audit is 1.5%. So if we put this, bring up my pencil again, as a decimal, 1.5% becomes 0.015, right? So this is the probability of an audit. So I'll call this A for audit. And so the probability of not getting an audit, so a complement, again, it's just 1 minus that. So 1 minus 0.015. Oops. I didn't put enough decimal places in my calculator. 0.015985. 0.985, right? So again, they want the odds here of being audited. And so if I divide 0.115, A over A is just equal to 1. So both of these are going to end up being over 1. So what we can do then is find our odds that is audited. So we take 0.015 and divide it by 0.985, and we get 0.0, oops, can't really see my points, sorry about that, 15. I'm gonna go one more decimal so you can see it is a different number, 2. So this is odds audited, and then odds against being audited. We take the 0.985 and divide it by 0.015, and we get 65.66 repeating, right? So if I round this is approximately, some little curlies here, a 66, because I'm going to round up. And what we do is put it over 1. So this is 66 to 1 chance of being audited. And I like to do it this way. The book makes it a little more challenging the way they explain it, I think. So I do it this way. This is 66 to 1. And I do B first, because A, again, is just the opposite. So it's the inverse. So this is just 1 to 66. So if you use the hint, they go through proving how this is all 1 and get it over 1. The easy way to think of this is if I divide 0.1015 by 0.015, that does equal 1. So that's where the 1 comes in effect. So the way I like to just do it is find the odds of being audited, find the odds against, round up to the nearest whole, because that's what it tells you to do here. So 65.66 rounds up to 66. I know it's going to be over 1 because of this little piece right here. And then the 2 are always inverses of each other. All right. Which pairs of events are independent? So the rules of independent from my reading, right, is the probability of A times, oops, the probability of B equals the probability of A and B. That little upside down U is the symbol for and. Right? So all we need to do is multiply this number by that number and see if it does equal that number. So 0.14 times 0.72 equals 0.1008, which is not that answer. So therefore, these are not independent. All right, so 0.75 times 0.85 equals 6375. So this one also is not independent. And then 0.5, clear, 0.58 times 0.18 equals, so that one is also not independent. So we're just checking to see if these are independent. None of mine were. Yours may be, because they changed the numbers. But the key is just remember you multiply A times B. If it equals what they say it does, then they're independent. Because remember, independence means what one, the outcome of one event has no effect on the other. Like flipping a coin. Flip a coin, I get heads. If I flip it again, I get heads. Just because I got head the first time, it does have no effect that I get heads the second. So therefore, there is no effect, sorry, so therefore they're independent. don't confuse that with mutually exclusive. Mutually exclusive means there is no and, right? So there's a difference there. All right, so if the probability the student has a Visa is 78, the probability the student has a MasterCard, the probability the student has both. Has either, so this is an or problem, right? So again, you can prove these are independent. The formula you need here for or, right? So this is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. I know you can't see it because I'm typing it, but you'll see in a second. All right, so that's the formula. So in this case, we have V, we have an M, and we have both means and. So you're going to take 0.78, you're going to add it to 0.17, and you're going to subtract 0.09. And if you multiply those together, see if you get 0.09, the answer B. All right, so I explained how to do this one. I'll let you go through and solve it your way. So here you can put the file into Excel. Is major independent of gender? So let's see here. This table consists of 200 business students. And so we need to find our ands here. So let's see here. Is major independent of gender? So let's do a couple. We need to find the probability of male. We need to find the probability of female, because there's our gender. Go into our table. And then we'll find the probability of being an accountant, the probability being economics, probability being in stats. So we have 90 males over 205. So that's just 90 over 205. And I'm not going to simplify yet so you can see where the numbers come from. Probability of female is 115 over 205. Right, success over total. That's how many females I have. Accountant is 105 over 205. Oops. Economics is 60 over 205. I'm not simplifying because I want you to see where the numbers are coming from. Probability statistics is 40 over 205. So now we have all our events. And so if I take and find the ands now, so to find accounting and female, that is right here. That's the and. So that's 50 over 205. So let's just try that one, because all we need is to find one that doesn't work, right? So 115 divided by 205 for probability of being a female times the probability of being an accountant is 105 divided by 205. And that equals 0.2873. So I multiplied female by A. So I multiplied these two together. So I got 0.287. And so now I just take 50 and divide it by 205. And I get 0.243. So the very first one I tried does not work. So I don't need to try them all because it doesn't tell me which one. It just says independent of gender. And so the first one failed. So then the answer is no. So you don't have to do all of them. Just pick one. And if it does work, pick another one, because for it to be independent, it has to work for all situations. All right, so next. Here's another odds against one. We've done those a few now. So the probability of international flight leaves is 32%. Departing, the probability arriving. Let me read this again. The probability of leaving the United States in departing, the probability that leaving the United States in, no, two different flights. Okay, so 32 and 53. To find the probability that leaving and departing is 16. Okay, given, here we go. So this is a given one. So the formula for given, and how I know it's a given, because it has the lovely word given in it. So the probability, and the way you read this, where is it? Given is right here, right? So that is like this little line right here. So what is the probability of fat leaving us is delayed, so that is D, right? Given the flight is this flight is 0.53, I mean, sorry, is P, so this is D given P. Well, this equals the probability of D and P all over the probability of P, right? And how I'd like to remember this is whatever is given always goes in the numerator. So if it had been the other way, P given D, then I would have put D in the bottom. So now we just use our numbers. So we see here's our and. So that is equal to 0.16. Ugly 6, sorry about that. And then the probability of P is on the bottom. So I divide that by 0.53. So 0.16 divided by 0.53, 0.301, 4 decimal places. So 0.30188 is what I got on my calculator. So the 8s become 9s. Right, and if they're independent, I think we've done this quite a bit of times here. 32 times 5.3, do you get 1.6? Click. Next. All right, so for this one is this a table, and you're basically doing all the things that we've just talked about in the previous problems, right? So the probability of S would be 313. I'm not going to simplify it. I'll put some of the numbers as you can see them over. And you can open up as an Excel if you want, but there's really no reason. There's the probability of our smoker, right? Because it's the total of smoke success over total. And you will have to simplify these. Probability of someone being white is 889 over 1,000. The probability of a smoker given white. So given that I'm white, so now I don't care about the black. All I care about is the white. So therefore, my new total is going to be the 889, right? Because all I given white, I'm a smoker, is 294. So this is just 294 divided by 889. The probability of a smoker given them black, again, it's the total of all I care about is this number now. So it's 111, and smokers are 19. So this is 19 over. So basically, you could do it the way we just did in the previous problem if you want and use the formula. But when you have a table, if you understand what the numbers mean, you can just pull them out. All right. And so smoker and white. Again, it's just the number in that spot. So that's the 294. But now I'm back to and, so it's over the total. Given is the only one that changes the total. Non-smoker, so be careful, N, and black is 92 over the total. And if I hit check my work, it's going to tell me they're wrong because I didn't simplify any of these, right? Oh, and it told me to put them in decimals. But just to show that I am correct. So 313 over 1,000 should just be 3.13. So just to show that these are correct, so you understand. Return to my question. So this becomes 0.313 because they're over 1,000, so that does make it a little bit easier. 0.889. And I'll do one more, and then that's it. So 294 divided by 889. 0.3307. So my fractions are correct, but they wanted decimals, but I wanted to show you where the numbers come from. And then another independent question. And our final question is another given problem, so use the formulas that you have here. Again, back to an independent question. So hopefully this video helps. I've solved a couple. Your number's gonna be different and some I didn't, so you can apply what I discussed there to your problems. As always, reach out to me if you have any questions. Have a good week.